Hello friends, welcome to UGPG Mathematics. In today's video, I am going to solve some questions from BHU Entrance Exam 2019. So let us start the video. The question is, we have given a ring R, M 2 by 2 matrices over Z. So, and we have given a set S which consists of set of all 2 by 2 matrices A 0 0 A, where this A is in Z, and this is a subset of R, and we have to just choose the correct statement from the given statements. So the first statement is S is a subring but not an ideal. The second is S is an ideal. Third is S is neither a subring nor an ideal. And the fourth statement is S is an ideal but not a subring. So let us just recall that if we have a set S which is a subset of given ring R, then in order to check that S is a subring or not, we just have to check the following properties. The first property is S must be closed under subtraction. S must be closed under multiplication, and multiplicative identity must be there in S. Must be there in S, the subset of a ring R. So if all these properties are satisfied by our subset S, then it is a subring of the original ring R. So let us check the first property. So is it true that this S is closed under subtraction? So if you take any two elements from S, namely take A 0 0 A, where this A is in Z, and take B 0 0 B, this is also an element of S, where this A and B are integers. So closed under subtraction means what? You just subtract one from the other, and the resultant is just A minus B 0 0 and A minus B. Right, now A is an integer, B is an integer, so A minus B is also an integer, and hence this this subtraction is in S. Right, so S is closed under subtraction. Now let us check another property. So this second property is it must be closed under multiplication. So take these two elements A 0 0 A, B 0 0 B. So these are the diagonal matrices, so their product is just a diagonal matrix. You just multiply the diagonal elements, right? So now A is an integer, B is an integer, so their product AB is also an integer, and hence this matrix is in S. So S is closed under multiplication. Now the identity element means this is the identity of our given ring R with respect to the multiplication. So what is the identity element in M2 by 2 matrices over Z? Clearly the identity element is the identity matrix of size 2 by 2, which is 1 0 0 1, and just note that this 1 is an integer, so this is in S, right? So S has this identity element with respect to multiplication. That means all these properties are satisfied by this S, and hence this S is a subring of, so S is a subring of our original ring R. Now let us check whether this is an ideal or not. So what is the condition for ideal? You just take R A, where this R is an element of the ring R and A is an element of the set S. Then this product must be in S, right? So let us check whether this is true or not. So let us take R is equal to, it is any 2 by 2 matrix, right? So take that R to be say 1, -1, 0, 0. So this is a 2 by 2 matrix over Z, ring of integers, and take that A to be, sorry, I must write this as say the capital A. So this is A with A 0, 0, A. Now this is an element of S, and this R is the ring R. Now let us just calculate the product. So RA is equal to 1, 0, 0, -1 and A 0, 0 and minus A, which is same as we just multiply the diagonal elements. So this is equal to A 0, 0 and minus A, right? But now just note that we want these two elements are equal. That means A must be equal to minus A. But it is not true for all the integers Z. For example, if you take A equal to 2, then 2 is clearly not equal to -2. That means this is not an element of S. So this condition for ideal is not satisfied here, and hence this S is not an ideal of the ring R. So S is a subring, but it is not an ideal of R. So this first option is the correct option. Let us solve another question. We have given a set of points 0, 0, 1, 0, 1, 2, 1, 1 and 4, 0, and the question is about when we express these boundary points as a convex combination of the extreme points, the values of lambda 1, lambda 2, lambda 3 are respectively. The options are, first option is lambda 1 is equal to 3 by 4, lambda 2 equal to 0, lambda 3 equal to 1 by 4. Second option is lambda 1 is equal to 3 by 8, lambda 2 is equal to 1 by 2, lambda 3 is equal to 1 by 8. Third option is lambda 1 is equal to 3 by 4, lambda 2 is equal to 1 by 2, lambda 3 is equal to 1 by 2, and the last option is lambda 1 is equal to 3 by 8, lambda 2 is equal to 0 and lambda 3 is equal to 1 by 8. So here we have given this set of some points. Let us first draw these points. So in R2 or in the xy plane, we have, now this is our x-axis, this is our y-axis. Now this 0, 0 is here, origin, then 1, 0 is here, then this is here say 4, 0. Now the next point is 1, 1 and last is 1, 2, right? Now these are the 5 points we have given. Now just look at these points. So let us just recall that if we have a set S is equal to, say we have some k points x1, x2, x3 and so on up to xk, then the convex hull of this set S is given by convex hull of S is equal to, you take summation of lambda I xi, where this I runs from 1 to k, such that this summation lambda I must be equal to 1 and all these lambdas are greater equal 0. That means you take all the linear combination, all possible linear combination of these points x1, x2 up to xk, such that this scalars lambda I, when you take the addition of these lambda i's, we get 1 and all these scalars are greater equal 0. Now just look at this. The extreme point, when you take the convex hull of these 5 points, we get, you just geometrically, this definition means what? You just take these points and draw the line segment between them. So these are all the extreme points, right? So the smallest convex set which contains these 5 points 1, 2, 3, 4 and 5 is called the convex hull of the set S. So this is nothing but this shaded region, which is a triangle shaped region. Now this is our point 1, 1, this is 1, 2, this is 1, 0, 4, 0 and 0, 0. Now we just have to find out the values of these lambda i's such that when you take the linear combination of extreme points, the convex combination of these extreme points, we must get a boundary point, right? So this question is about this combination. So the values of lambda, when you take the addition of lambda i's, we must get 1. So let us just check this option. So this option, when you take addition, it is 3 by 8 plus 0 plus 1 by 8, which is clearly 1 by 2. So here the summation lambda I is equal to 1 by 2, which is not equal to 1. So this is not true. Now second, you take the addition of these two. So 1 by 2 plus 1 by 2 is 1 and 3 by 4 plus 1 is clearly not equal to 1 when you take the addition. So this is also not the correct option. Now when you check the addition of these lambda i's, it is equal to 1, but let us check whether this combination gives us a boundary point or not. So let us check the first option. So first option is, now just look at this. What are the extreme points for this region? The extreme points are just this 0, 0, 4, 0 and 1, 2. So just write the linear combination. Say if I take that lambda 1 is equal, from the first option, lambda 1 is 3 by 4. So let me write down the boundary points here. So these are 0, 0, then 4, 0 and 1, 2, right? So take lambda 1 3 by 4, then take the point, say 1, 2, then plus lambda 2 is 0, take the another point, it is 0, 0, plus lambda 3 is 1 by 4, take the last point 4, 0. So what is this combination? It is 3 by 4, 6 by 4, plus this is 0, plus 1 by 4 into 4 is 1, 1 by 4 into 0 is 0. Now this is just same as 3 by 4 plus 1, 6 by 4, which is same as 7 by 4, 6 by 4. Now this point is, it must be a boundary point. So let us check this is a boundary point or not. So this is our question. Is this a boundary point? So the boundary points are just the points on these lines, right? From this line or this, right? These are all the boundary points. So how to check that? You just take the equation of this line. So what is the equation of this line? Now this is the point 0, 0, it is 1, 2. So this is clearly y is equal to 2x, right? Because when you put x equal to 1, we will get y is equal to 2. Clearly when it is x equal to 0, y is equal to 0. So the line joining these 2 points is y is equal to 2x. So now let us just look at this line. So this line, what is the equation of this line? We have 2 points 1, 2 and 4, 0. So call this as x1, y1, x2, y2. So the equation of this line is y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1, right? So put the values, we will get y minus y1 is 2, y2 is 0, it is 2, then x minus x1 is 1, then x2 is 4 minus x1 is 1, right? Now just simplify this. So y minus 2 is equal to minus 2 times x minus 1 divided by 3. So this gives us y is equal to minus 2 by 3 plus minus 2 by 3x plus 2 by 3 plus 2, right? So this is just y is equal to minus 2x by 3 plus 8 by 3, right? Now just look at this option. So when you put, so let me write here, so this line is just y is equal to minus 2x by 3 plus 8 by 3, right? So this point is somewhere here. Similarly, you just find this equation of this line. So clearly this is on y-axis, so that means, sorry, it is on x-axis, so the equation is y is equal to 0. Now let us check this point is boundary point or not. Clearly this 7 by 4 is to the right of this one, right? So you just check for, and this y coordinate, second coordinate is not 0, so it is not on this line, so that must be here. So let us check this point 7 by 4 comma 6 by 4 satisfy this equation or not. So you can either put the value of x and check for the y, and or either put the value of y and check for the value of x. So I will put the value of x. So when you put x is equal to 7 by 4, we get this y is equal to minus 2 by 3 into 7 by 4 plus 8 by 3. So y is equal to minus 14 divided by 12 plus 8 by 3. Now multiply and divide by 4. This will give us 32 minus 14 by 12. So which is equal to, this is right, 18 by 12, which is same as 6 by 4, right? So when you take x is equal to 7 by 4, we will get y is equal to 6 by 4. That means 7 by 4 comma 6 by 4 is on the line y is equal to minus 2x by 3 plus 8 by 3. That means this point is a boundary point. So this is true. Similarly, you take the values, various values of these extreme points, and take the values of lambda and take the linear combination, you will get the point which is a boundary point. So this first option is true. But let us see why this second option is not true. Now you can just see that when you take the second option with this lambda 1 is equal to 3 by 8, lambda 2 is equal to 1 by 2 and lambda 3 is equal to 1 by 8, and you take the boundary points are just 0, 0, 1, 2 and 4, 0, and take the linear combination of this. So it gives us 3 by 8 into 0, 0 plus, sorry, these are extreme points, and then this is 1 by 2 into this point 1 comma 2 plus 1 by 8 lambda 3 into the last extreme point which is 4, 0. And what is the linear combination? It is just 0, 0 comma 0 plus 1 by 2 comma 1 plus 1 by 2 comma 0, and just take the addition. So it is 1 by 2 comma 1 by plus 1 by 2 plus 0 is just 1, 0 plus 1 plus 0 is 1. Now as we can see that this point 1 comma 1 is not a boundary point because it lies in the interior part of this region. So clearly this 1 comma 1 is not a boundary point, and hence this second option is not true, because when you take the convex combination, we are not getting that combination as a boundary point. So the first option is the correct option. Let us solve another question. We have given a 3 by 3 real matrix with the characteristic values as -1, 1, 0. Then which of the following statements are true? So first is a cube is equal to I3, identity matrix of size 3. Then second is a cube is equal to 0. Third is a square is equal to a. And last is a cube is equal to a. Now we will effectively use Kelly's theorem, which says that every matrix satisfies its characteristic polynomial. Now we know that these characteristic values are the roots of characteristic polynomial, right? So from these roots, first find out the characteristic polynomial. Now -1, 1 and 0 are the roots. That means x plus 1, x minus 1 and x minus 0 are the factors of the characteristic polynomial, right? Now that means this, I will denote the characteristic polynomial by p of x. So this p of x must be equal to a times x plus 1, x minus 1 into x minus 0, right? Because these are the factors. So this is the coefficient of the term x cube, right? Because it is a 3 by 3 matrix. But one should note that this polynomial is always a monic polynomial. That's why this a must be equal to 1. So this p of x is just equal to, which is the characteristic polynomial, it must be x plus 1 into x minus 1 into x, right? So this is just equal to x into x square minus 1, which is same as x cube minus x, right? Now this is the characteristic polynomial of the matrix, say A. So the polynomial is satisfied by this matrix A. So P of A must be equal to 0. So P of A equal to 0 means what? You put A instead of this x. So this is just a cube minus a. It is equal to 0. So this gives us a cube is equal to a. That means this fourth option is the correct option. I hope you like this video. Thanks a lot for watching. Please like, share and subscribe if you find this useful. And also press that bell icon to get the all updates. Thank you.